welcome to this episode of Geography Girl. Today is a tribute to our eldest relative, the kingdom of the fungi, who are a rather unassuming family but have some incredibly fascinating abilities to help protect us against the onslaught of climate change. Fungal networks are deeply threatened. The use of chemical fertilizers, pesticides, and deforestation from the agricultural industry, as well as urbanization, are all threatening the lives of this ancient species. Fungi thrive in forests. However, we lose around 12 million hectares of forest land on a yearly basis. The UN has set a global goal of ending deforestation by 2030, aiming to prevent, halt, and reverse the degradation of ecosystems on every continent and in every ocean. But you might not be surprised to know that deforestation actually increased 4% worldwide in 2022, and that we are 21% off track to meet that 2030 goal, according to the World Economic Forum. Wildfires. As the flecks of ash settled on a desolate, blackened and brittle landscape in the North Bay, California, burnt by a raging wildfire in 2017, a local student looked on in despair. A worrisome warning of what was to come, Annandale State Park and Hood Mountain Regional Park were defined by death. Heartbroken by the destruction of her favourite nature reserves, Gabrielle Smith, an associate professor in biology, set about taking a soil sample. I wanted to know how these ecosystems that on the outside look so burnt and so destroyed might have been affected at a level that is not so obvious, the soil fungi that I study. And what she found was pretty surprising. When we're talking about mushrooms, there's more than what just meets the eye than the fruit. Below the ground is a complex and intricate warren of roots and microbes that are living up in the soil. These microbes play a key part in the ecosystem as they help the trees grow and catalyze decomposition. Smith's research focused on two separate ecosystems, the oak woodland and the mixed evergreen forest, and produced some very interesting insights. They found that the oak woodland ecosystems were far more resilient and even rely on regular fires to thrive. Oak woodlands are often treated with prescribed burns to maintain a healthy ecosystem. Fires clear leaf litter, branches, and create optimal growing conditions for different types of seeds. Fire can help with insect and disease control and can prevent other trees from invading oak forests. They found that burnt soils had a different microbial makeup than unburnt soils. They think that this might be because oak forests use burnings to reset the soil and thus can do it faster than in evergreen forests. It's not just in the soil. Fungi is crucial in breaking down wood. Decaying fungi grows through the wood's vascular tissues, destroying cell walls. This causes the wood to crumble and to return to the soil as soil. Dr. Limbodi, professor of fungal ecology at Cardiff University, said, "It's very important that natural decomposition occurs in ecosystems, because this will accumulate good organic matter in the soil, and the soil will have good water-holding properties." She added that this is preferable to burning, which would result in carbon dioxide and water just going immediately into the air. Small fires are part of the natural rhythm of the woodland ecosystem. It's nature's way of thinning out the woodland. However, research has found that since the 1980s, forest fires are of course becoming more severe. In the US, the approach has always been to suppress forest fires using planes and fire suppression chemicals, which in themselves have hazardous impacts on the environment. With a government commitment to reducing these hazardous fuels, the alternative is to cut down pines, leaving the piles of trunks in the forest floor. This is excellent kindling. There are 140,000 piles of wood in forests in North Carolina alone, and so researchers are experimenting with inoculating piles with fungi in order to break them down. This is a risky business. You can't just go spreading your mycelium seed. Ecosystems are deliberately and sometimes delicately balanced, and you don't know the impact of oversaturating one part of the ecosystem with a particular strain might be. It might be super antagonistic, it might disrupt existing species, so it needs to be carefully managed. This field of research is particularly important given the urgency of the world's soil situation. The UN has warned that 90% of the Earth's topsoil could be degraded by 2050. Land degradation cripples our ability to fight climate change and biodiversity collapse, says Heidi Hawkins, who is a South African author and scientist. Soil is a key carbon sink. The top metre of the world's soil contains 3 times as much carbon as the Earth's entire atmosphere. Fungi is playing a key role in the soil's ability to retain carbon. Roughly 75% of the Earth's terrestrial carbon is stored in soil through the process of photosynthesis. Plants give fungi a massive 4 gigatons of carbon each year, which equates to the annual emissions of the US and China combined. Arbuscular mycorrhizal fungi, or AMF, is a particular type seen as a promising technology for sustainable farming. This particular variety is a biofertilizer which can enrich the soil fertility as well as reduce atmospheric CO2. This has incredible potential as the world moves towards sustainable farming techniques. The biofertilizer market is reaching more than 2 billion globally. Described by Wired magazine as the humble heroes in the climate war, they report that if we can harness the untapped power of fungi and apply it to farmland, 1.8 billion hectares globally, it could result in the largest carbon drawdown event in history. Mycelium fungi has broken into the worlds of food and fashion. When grown in a controlled environment and processed, it resembles a leather texture known as mylo. The likes of Lululemon, Adidas and Stella McCartney have released products as a vegan substitute. My Forest Foods have also announced that they will be growing 300 pounds of mycelium in their vertical farm in Albany, New York, which could make 1 million pounds of their imitation bacon. And this is all very interesting stuff. I hope you enjoyed this episode today. It's a short but sweet one, and I will see you next time.